name's Michael.
And my name's Mike.
And I'm Sam. Let me show you the transmitter for our ECE 2001 device. As you can observe, here we have our AUX input. It goes all the way over here. Now, first things first is we have to look at the power distribution for the circuit, and this is accomplished by putting the battery at the plus and minus rail, and then splitting it up with the potentiometer right here. Afterwards, we had the positive source on this rail so that we could be able to take the DC for the DC offset over here when we put it back into the bias T. Now over here we have the microphone. So the microphone signal enters and then gets amplified, where we have volume control for the microphone itself. And the gain, given that this is a 10.2 kilo ohm resistor and this is 1 kilo ohm, should be around 10 plus 1, which is 11. Now, for the AUX signal, it enters here. We ground the other terminal at the virtual ground, accomplished via the second terminal, the potentiometer and the power distribution. And this, given that the phone can produce around 600 millivolts, is directly just put into the node and joined with the output from the capacitor on this little positive rail. As you can see, it goes here and the cardboard is covering that part. And then the filter capacitor filters the signal primarily so that we can only get the AC from it. The inductor is for the DC offset so that we only get the DC signal. And then this is a resistor so as to protect the laser from too much current. And now the result was a laser of around 4.5 volts of varying color. So let's turn on the meter. It's playing, take it to the middle of a song. And as you can see, the laser's intensity changes, which is descriptive of the varying voltage that will be present at the solar cell. And that's the transmitter.
Alright, so here we have our receiver circuit. So once the laser is shot to the receiver, it hits the solar cell. And the reason why we use the solar cell versus other photodiodes like other photodetectors like the photodiode is because once the laser hits the solar cell, it gets spread out over the solar cell, and this creates a large voltage. Also, it's important that we cover the solar cell with our hand or maybe with like a piece of paper to trap the ambient light that is surrounding. Alright, so once it's fed in through the solar cell, it goes through the capacitor where the sound is filtered, and then it goes directly to our op amp. Now our op amp has a gain of 1500 because there's 3 mega ohm resistors in series, and that's over 2 kilo ohm resistor. And then once that sound goes through the op amp, it's amplified and then it's fed through the speaker, which is powered by one of our 9-volt batteries over here, and then we adjust the potentiometer to figure out what volume we could hear it at.
Alright, so now we're going to see the circuit in action. The music is already playing on the phone over here. So what we're going to do is we're going to plug this wire into the terminal here, activating the laser. And as you look over to the other side of the room, the laser is already hitting the solar cell. We're going to follow me to the other side. And now,
You're in the way.
I'm in the way. We're going to back away from the laser. Laser is hitting the solar cell, and music will be coming out through the speaker there.
As soon as we plug it in.
As soon as it's plugged into the battery there. Alright, so adjusting the volume using the potentiometer, we're going to start hearing an output coming from the speaker. And there you have it, beautiful music, the beautiful music of Africa by Toto.
Finally, one more thing to know is that the signal from the microphone is approximately 20 to 30 millivolts, and that from the AUX we know is around 500. So we need to amplify this to around 330 and that to 500 so they're comparable strength before we put them into the filter capacitor. Otherwise, one will be extremely louder than the other, and we won't be able to hear the other one. Thank you.